Welcome, dear students. Our today's topic is logistic regression analysis. What is logistic regression? It is a statistical method which we utilize to predict the probability of any binary outcome which is based on one or more independent variable. By binary outcome, we mean two outcomes. So, what we can say in simpler terms is that it helps us to classify the data into two categories. Very often, the outcome that we want is to predict the regression analysis is in simple two ways, like yes or no answer. We can take an example like a bank want to determine whether to approve a credit card application or not. So what we can do is, in such case, for the approval of application, the bank can give a value 1, and for rejection, the bank can give a value 0. It's a very powerful tool, logistic regression, for estimating the probability of positive outcome, like credit card approval, loan approval, etc., based on various factors. So, any agency or any organization, they can use logistic regression where we can analyze the factors and we can build a model which helps us to predict the probability of approval for a given applicant, if we take example of credit card approval or loan approval, etc. So in logistic regression, what we do is we model the relationship between independent variables and the dependent variable, which is log odds of the outcome. So what we can say in essence is the logistic regression is a very powerful tool for making predictions and understanding factors which influence binary outcomes, means two outcomes. So the key characteristics of logistic regression, let us discuss that. Binary outcome means the target variable has only two possible values, which are often represented as 0 and 1, or we can say yes or no. So logistic regression model gives us the probability, and what probability it gives us? It gives us the probability of the positive outcome, right? 1, the occurrence of positive outcome. And based on the calculated probability, data points are assigned to one of the two classes, and this probability estimation, this function transforms the linear combination of independent variables into values between 0 and 1. And as you know, probability is measured between 0 and 1 also. So therefore, these values are sort of representing the probability. A few common applications of logistic regression, though it is being widely used in various fields due to its simplicity and interpretability. But few common applications are marketing, where if you would like to predict the customer churn, if you want to see the response to our advertising campaign, or if you want to check the product preference of the customers. In finance, it is used in credit scoring, fraud detection, investment analysis. Similarly, it has in healthcare, email, etc. A lot of applications in almost all the fields. Let us understand the logistic regression by help of a case, small case. This case I've taken from a book, Statistics for Business and Economics, 13th edition by Anderson, Sweeney, Williams, where we are considering application of logistic regression involving in direct mail promotion, which is being used by a store known as Simmons store. So this Simmons company, they own and they operate national chain of apparel, women apparel. So what they have done is they have printed 5,000 copies of an expensive 4-color sales catalog. And this catalog includes a coupon that would provide a $50 discount on purchase of $200 or more. These catalogs are expensive, and Siemens would like to send them to only those customers who have high probability of using the coupon. The management of the store, it believes that annual spending at the store and whether a customer has their own credit card, these are the two variables that might be helpful in predicting whether a customer who receives the catalog will use the coupon or not. So what Siemens did, it conducted a pilot survey using a random sample of 50 credit card customers and 50 other customers who do not have Siemens credit card. Siemens sent the catalog to each of these 100 customers selected, and at the end of the test period, Siemens noted whether each customer had used her or his coupon or not. So we have sample data for the first 10 catalog recipients. We can see here is the data in this table, and you can see there are 10 customers in column 1. Column 2 gives us amount that customer has spent in dollar thousands, right? And credit card information is in column 3, which is being coded as 1 and 0. 1 if the customer has Siemens credit card, and 0 if the customer doesn't have Siemens credit card. And you could see the fourth column is the coupon column, right? If it is 1, then it is recorded if the customer has used the coupon, and if it is 0, it is recorded if the customer has not used the coupon. So we can see from this table is we have two independent variables, annual spending, which is in column 2, and Siemens card, which is in column 3. And we have one dependent variable, which is coupon, which is in column 4. Now, this dependent variable in this case is binary, meaning it can only take on two values, either 0 or 1. We have seen it takes 1 if the customer has used the coupon, it takes 0 value if the customer has not used the coupon. And due to this limitation of binary scenario, the traditional ordinary multiple regression model is not suitable for such data because traditional ordinary multiple regression model requires the data to be at least on interval scale. So this case is a typical situation where logistic regression is employed. So let us understand the basic of logistic regression first. You could see this is the logistic regression equation. We could see that this is the basic binary logistic regression model where you could see the dependent variable y, it can only take values 0 and 1, and the predicted probability of y is equal to 1 for specific values of x1, x2 up till xp is directly calculated from the estimated equation. When we convert this, we can write it as the expected value of y, which is denoted as EY. It can be interpreted as a probability. So frequently the logistic regression is expressed in the following terms: probability of y is equal to 1 given x1, x2 and other independent variables. How do we estimate the logistic regression equation? So we utilize the least squares method to find the best fit line for linear and multiple regression method, and this method estimates the model's parameter. But in logistic regression, because it has a non-linear form, it makes it harder to calculate these estimates. Therefore, nowadays we utilize computer software which are very common to provide the estimated coefficients in regression model. Since this logistic regression makes it harder to calculate these estimates because it is in non-linear form, so we utilize computer softwares to provide the estimates of coefficients of regression model. So when we use estimates, the logistic regression equation takes this shape. You could see the beta naught, beta 1, beta 2 are replaced by B0, B1, B2. As you know, beta naught, beta 1, beta 2 are known as population parameters, while B0, B1, B2 are sample statistic which are used as estimate for population parameter. So this is the estimated logistic regression equation. To get these B0, B1, B2, we utilize computer softwares to get these values. We can see the variable definition of this equation. Here y is equal to 0 if the customer did not use the coupon, and is equal to 1 if the customer has used the coupon. And X1 is the annual spending at the store, which is in dollar thousands. And X2 is again binary, where it is 0 if the customer does not have the credit card, and it is 1 if the customer has the credit card. So because in our case we have only two variables, so our equation reduces to this form. And when we put this data into the computer software like SPSS, Minitab, SAS, R, any of the softwares, we'll get the results. So we have pulled out the results from there. So we got B0 as minus 2.146, B1 as 0.342, B2 as 1.099. And when we put these estimates of B0, B1, B2 in the logistic regression equation, what do we get is e to the power minus 2.146 plus 0.342 x1 plus 1.099 x2 divided by 1 plus e to the power same thing minus 2.146 plus 0.342 x1 plus 1.099 x2. Now, since we have the coefficients from the software B0, B1, B2, we'll put them in equation, and you will see we are finding it for the customer. This customer has spent $2,000 annually, and this customer doesn't have Siemens credit card. So we would replace the X1 with 2 because it is in 1000. So we'll for 2000 we'll write 2, and we'll replace X2 by 0. So you could see by replacing it, we have e to the power minus 2.146 plus 0.342. Within bracket you are seeing 2, which is we have replaced x1 by 2, plus 1.099 within bracket you could see 0. We have replaced x2 by 0 in the numerator also and in the denominator also. So we are writing it as y hat. We use hat for the estimated value. So we are getting estimated value for y. When we solve it, we get a value of 0.1882. And if we substitute x1 2 and x2 as 1 in place of 0, now we are putting 1 for x2. What we are trying to do is we are trying to find out probability that a customer who spent $2,000, who has spent $2,000 last year, and he also has the Siemens credit card, right? And he will use the coupon also. So when we replace x1 by 2, you could see in the numerator we've replaced x1 by 2 and x2 by 1, and similarly in the denominator also we've replaced x1 by 2 and x2 by 1. So we've got the estimate as 0.4102. Now what do we understand by this? By this, what we are understanding it, the probability or the chances of the customer using the coupon depends on whether they have a Siemens credit card, right? The customer who have spent $2,000 and who doesn't have this Siemens credit card have about 18.82% chances of using a coupon. While the customer who have spent $2,000 and they have Siemens credit card, they are more likely to use the weapon. As you could see, the probability has increased to 41.02%. So what we can see is the customers with the credit card are more likely to use the coupon. So let us optimize this information. How can we target customers for Siemens new promotion? So what we've done is we've taken about 7 annual spendings of 1,000, 2,000, 3,000, 4,000, 5,000, 6,000 and $7,000. What we can see is the customers who have Siemens credit card, they are more likely to use the coupons. As you have seen, the probability was 18.82% for those who do not have Siemens credit card and 41.02% who have the credit card. Now what we've done is, in this table you could see, we've taken 8 annual spendings, 1,000, 2,000, 3,000, 4,000, 5,000, 6,000 and 7,000. And whether they have credit card or not is on left hand side, yes or no. And you could see we've given their probability of using the coupon, right? So if the Siemens wants to utilize this information given in this table, because this table is presenting the predicted probabilities of annual spending of customers with and without Siemens credit card, and these estimates are ranging from 1,000 to 7,000. It can guide the store in having targeted marketing efforts. So let's say Siemens has decided that we will give the catalog where the probability is more than 0.4. So we can see probability more than 0.4 for credit card, yes, comes after 2,000. 2,000 is 0.41, then for 3,000 it's 0.49 and so on. So what from this table Siemens can decide is, they can target customers who are having Siemens credit card and their annual spending is $2,000 or more. And then you could see the second row, the probability of 0.4 is coming for 6,000 and 0.5 is coming for 7,000. So since they have a threshold of 0.4, so they can decide that the customers who doesn't have Siemens credit card and their annual spending is 6,000 or more, they can give them the catalog to use the coupon. So based on this probability estimate, you could see 5,000 is just 0.39, it's just below 0.4. So they may want to reconsider their coupon strategy, and the customers without a credit card who spend $5,000 annually, they have a good chance, 39.22% of using the coupon. So they can also change their strategy for the customers who doesn't have credit card and who are spending $50,000 or more, to give them coupon also. What we've seen is Siemens store has utilized the data of annual spending, credit card possession and the usage of coupon for classifying their customers or segmenting the customer base, whether to give them the coupons and catalogs or not. So therefore, to summarize what is logistic regression, let us summarize it once again. It is a statistical technique where we predict the probability of a binary outcome. It could be yes, no, it could be true, false, it could be 1, 0, based on one or more predictor variables or independent variables. So it's particularly useful for the task like where we want to do classification, where we want to see whether a new data point belongs to one or two category or not. For example, we want to check whether a new applicant who is applying for loan to a bank, whether to give loan to that customer or not. It can also be used for prediction, where we can forecast the probability of occurrence of an event. We can use logistic regression for modeling relationships also, where we try to understand the relationship between the predictor variable and the binary outcome, or independent variable and dependent variable if dependent variable is binary. So what are the key characteristics of logistic regression? Number one, the dependent variable has to be binary, means it has to have two outcomes, yes, no, 1, 0, etc. It follows logistic function, right, which we also call as sigmoid function, where we are trying to map the linear combination of predictor variable to a probability between 0 and 1. And finally, it has a lot of applications in wide range of areas, including medical research, marketing research, finance, and social sciences. Thank you very much.